Hello everyone. Now we will see common types of internal combustion engines and how reciprocating piston for stroke cycle engine works. Types of IC engines. There are several types of internal combustion engines. The most common types are: number 1, reciprocating piston engine. Depending on their ignition system, there are two types: spark and compression ignition. In spark ignition engine, air-fuel mixture is ignited by spark plug. And in compression ignition engine, the high temperature created by compression ignites the mixture. Number 2, Wankel rotary engine. The Wankel engine uses a rotor instead of pistons. The rotor moves in an epitrochoidal path within a chamber. As it moves, it alternately creates expanding and contracting volumes within the chamber, allowing for intake, compression, power and exhaust strokes. Number 3, gas turbine engine. Gas turbine engines operate by burning fuel in a combustion chamber to produce high pressure and velocity of gases. These gases expand at one end and producing thrust or mechanical power at the other end. Each type of internal combustion engine has its advantages and disadvantages, making them suitable for different applications based on factors such as power output, efficiency, size and cost. Our second topic is how reciprocating piston for stroke cycle engine work. The four-stroke cycle, also known as the Otto cycle. A stroke is one movement of the piston either from top dead center, TDC, to bottom dead center, BDC, or up from BDC to TDC. The term stroke also refers to the physical distance between these 2 points. One stroke of the piston moves the crankshaft through 1/2 of revolution, 180 degrees. Almost all engines on the road today operate on a cycle of the piston strokes. The strokes are the intake stroke, compression stroke, power stroke, and exhaust stroke. This cycle turns the crankshaft through to revolutions, so power is created every 720 degrees in each cylinders, and then the process begins again. Now let's see each stroke one by one. Number 1, intake stroke. During the intake stroke, the intake valve opens and the piston moves downward from TDC to BDC, creating a vacuum within the cylinder. This vacuum draws in a fuel-air mixture from the intake manifold into the combustion chamber. Number 2, compression stroke. After the intake stroke, both the intake and exhaust valves close, sealing the combustion chamber. The piston then moves back up from BDC to TDC, compressing the mixture within the cylinder. This compression creates high heat, making the mixture more combustible. Number 3, power stroke. At the top of compression stroke, the mixture is compressed to maximum. The spark plug in spark ignition and heat created by compression diesel ignites the mixture. This expansion forces the piston back down from TDC to BDC, creating power that is transmitted to crankshaft. Number 4, exhaust stroke. Finally, with the piston at BDC, the exhaust valve opens while the intake valve remains closed. The piston moves up from BDC to TDC, pushing the burning gases. Once the piston reaches TDC, the exhaust valve closes and the intake valve opens again, starting a new cycle. This sequence of 4 strokes completes one full cycle of operation, during which the engine produces power continuously. The cycle is repeated multiple times per minute, depending on the engine's speed and load, to generate the necessary power to propel the vehicle or perform other mechanical work. Thanks for watching.